Welcome back. And so hopefully you have determined whether or not the user entered day 14, and hopefully your code looks something like this. I have starting on line 17. I've defined a Boolean variable called is14th, and I have set that to represent equal or whether or not day, which is what the user entered for the day of the month, whether that is the 14th, and relations will return a Boolean result depending on whether or not the relation holds. And then I can have is 14th. Again, this Boolean value is a perfectly good condition. It's an expression that resolves to a Boolean. And if it's true, then I print day is 14th. This time I did add an else clause which will execute if and only if is 14th is false, and it says it's not the 14th. So let's run this real quick. Let me save that. And let's run this as a Java application. And what I put for the month, as far as I'm concerned right now, isn't real interesting. And I will put the first of the month, and the month is February, but it is not the 14th down here because I did not enter a day of 14. Let's run this again, and I'll still enter February. Again, that has no bearing on what happens to is 14th. And this time I will enter 14th, and you see day is 14th is printed, which is coming from line 18 up here. So hopefully you have that. Now we are going to figure out if the user entered Valentine's Day, which is month of February and day of 14th. So we'll need to relate is Feb and is 14th. Before we get into that, let me summarize the logical operators that we have. We have three of them: and, or, and not. And the and the or take two operands similar to arithmetic plus. If I want to add I and j, I say I plus j. The plus sign takes the I on its left and the j on its right as operands. This third column here, and it's not going to let me mark that, is the and operation. And you can see its symbol or its representation is a double ampersand, and it takes two operands, one on the left, one on the right. And over here in these first two columns, I have all possible variations of two Boolean values. They can both be true, as they are on this top line. One can be true and the other false, or the one can be false and the other true, or they can both be false. So that's one nice thing about Boolean values. If you have a small number of them, you can actually explicitly list out all the possible combinations you have to work with. The definition of the and operator is that they must both be true, and if they are both true, if x and y are both true, x and y will be true. Otherwise, x and y will be false. If x is true and y is false, x and y is false. If x is false and y is true, x and y is false. And if they're both false, x and y is false. The or operator, which is two vertical lines, that's the uppercase backslash on your keyboard probably, also takes two operands, and x or y is true if either x or y or both are true. So if x is true and y is true, X or Y is true. If X is true and Y is false, X or Y is true. If the combination is false and true, X or Y is true. It's only if X and Y are both false that the OR operation is false. The last logical operator is the NOT operator. That's the exclamation point, and it only takes one operand, and it's to the right, and its role in life is to flip the value of whatever the value to its right is. So if X is true, not X is false. If X is false, not X is true. So this is the truth table defining all the logical operations that we have to play with. I'll try to give you a bit of a Venn diagram view of these operations. The AND operation, if I have the X is true in this circle or area to the left here, and everywhere else X is false except in this yellow area here. And if I have Y is true in this red area, in this red area here, let me see if I can move that back. If I have Y true in this red area and everywhere in the gray Y is false, then X and Y is true only in the intersection of these two circles. If I look at the OR operation, again, X is true inside the yellow and everywhere else X is false. Y is true inside the red area. Everywhere else Y is false. X or Y is true anywhere it's not gray in this picture. If X is true, it's X or Y is true. If Y is true, X or Y is true. If they're both true, X or Y is true. And for the NOT operator, if I have X being true inside this green area here, and X false everywhere else on the outside, not X is true everywhere else on the outside, and not X is false inside the green circle there. So now let's see if we can figure out if it's Valentine's Day. And the first thing we have to figure out is, what does Valentine's Day mean? Well, it means the month is February and the day is February. Both must be true. If it's February 13th, it's not Valentine's Day. If it's March 14th, it's not Valentine's Day. So if I take as my X value is Feb and my Y value is 14th, the is Feb and is 14th would both have to be true for me to have Valentine's Day. And if I look at my possible logical operations here, it's the AND operation that's going to give me the value I want for both being true, and Valentine's Day will be the AND operation of is Feb and is 14th. So let's see if we can write that. I'll declare a primitive Boolean, and I hope I spell Valentine's right, and I will initialize that to is Feb and is 14th. And I will put that into an if statement. and print that out. And let's run this right quick just to see if it really works. So if my month is 1 and my day is 14th, it's the 14th, but it's not Valentine's Day. This system.out.println on line 22 was not executed because it's on the true path of this if statement, whose condition is Valentine's Day. If I run it again and give it a month of 2, but the 13th as a day, again, it's not the 14th and it's not Valentine's Day. If I run it again and give it February and 14th, the month is February, the day is 14th, and I get my Valentine's Day printout here from line 22. Now, just like up here on line 14, I can put these relational operators straight into my if statement condition. So let me rewrite this if statement. That will be month equal to and day equal 14. And let me put an else here. Just to point out that it's not Valentine's Day. So these are the exact two relations that I used earlier. And this relation resolves to a Boolean value. The relation is done before the logical operator. This relation resolves to a Boolean value, which gives me two Boolean values on either side of this AND operation. And that's the way things are commonly written. And if I run this and say month 1, day 14th, I get not Valentine's Day. If I run it again for month 2 and day 13, it's February, but it's not Valentine's Day. If I run it and have month 2, day 14, it's still Valentine's Day. Okay, so I'm going to stop this video, and I want you to modify this program and determine if the user entered your birthday. Okay, and we'll be back in the next video.